Hey everybody, this is Jolie and I'm going to go over the components of an X-ray tube head. X-rays are used in dentistry to produce dental radiographs, which are images produced on a receptor that show teeth and other structures in the mouth. Dental images are a necessity in patient care as they show things that you cannot see clinically. If a patient only has an exam and no X-rays, then many things can go undetected. For dental hygienists, it is important for us to be able to check the bone levels of teeth for any signs of periodontal disease. The use of X-rays has progressed tremendously over the years due to research and different techniques. This is an example of a dental tube head. The tube head is one of three parts of the dental X-ray machine. The X-ray machine also contains a control panel that is used to adjust different settings in order to take radiographs, and the extension arm, which is used to move the tube head around into the correct position for taking radiographs. The tube head is a tightly sealed, heavy metal housing that contains the X-ray tube and produces dental X-rays. Let's go over the different components of the tube head. First, we have the metal housing, and that's also known as the metal body of the tube head that surrounds the X-ray tube and transformers and is filled with oil. It protects the X-ray tube and grounds the high voltage components. The insulating oil prevents overheating by absorbing the heat created by the production of X-rays. Next, we have the tube head seal. It's an aluminum or lead glass covering of the tube head, and it allows X-rays to exit the tube head. It keeps the oil in and also acts as a filter to the X-ray beam. Next is the X-ray tube, right here. It's known as the heart of the X-ray generating system. It is critical to the production of X-rays. It is a glass vacuum tube that contains no air. It is about 1 inch in diameter, and it contains the leaded glass housing, cathode, and anode. We'll talk more about this in a minute. The transformer, which we will also talk about in a minute, right here, and they are either used to increase or decrease the voltage in an electrical current. It contains the step-up transformer, step-down transformer, and the auto transformer. Aluminum discs. These are sheets of 0.5 millimeter thick aluminum placed in the path of the X-ray beam, and they filter out the longer, less powerful X-rays. The lead collimator is a lead plate that has a little opening in it, and it restricts the size and shape of the X-ray beam. The position indicating device, or PID, is an open lead-lined cylinder that extends from the opening of the tube head. It aims and shapes the X-ray beam. Now let's talk about this X-ray tube. The leaded glass housing, or glass envelope, is a leaded glass vacuum tube that prevents X-rays from escaping in all directions. There's an unleaded glass window that allows for the X-rays to exit the tube and directs it toward the aluminum discs, lead collimator, and PID. The cathode, or negative electrode, consists of tungsten wire filament in a cup-shaped holder made of molybdenum. The purpose of the cathode is to supply the electrons needed for X-rays. The tungsten filament is a cooled wire made of tungsten which produces electrons when heated. The molybdenum cup, or electron focusing cup, right here, focuses the electrons into a narrow beam and directs them across the tube towards the anode. The anode is a positive electrode consisting of a wafer-thin tungsten plate embedded in a copper rod, and the purpose of the anode is to convert electrons into X-ray photons. The tungsten target serves as a focal spot and converts the incoming electrons into X-ray photons. The copper stem dissipates the heat away from the tungsten target. So that pretty much covers all the components of the X-ray tube head. Now, let's go over how X-rays are produced. The production of X-rays relies on the electrical energy to supply the flow of electrons through a conductor. This is called an electrical current. The electrical current is called the direct current when the electron flows in one direction through the conductor. An alternating current is when you have electrons flowing in two different directions. Rectification is the conversion of alternating current to a direct current. The X-ray machine is always working to make sure the flow of electrons is going in one direction or has a direct current. Amperage is the measurement of the number of electrons moving through a conductor. Current is measured in amperes or milliamperes, MA. Voltage is the measurement of electrical force that causes electrons to move from a negative pole to a positive one, as in the case with the cathode, which is negative, and anode, which is positive. Voltage is measured in volts or kilovolts, kV. These can all be adjusted on the control panel that I mentioned earlier as being one of 3 parts of the X-ray machine. A circuit is a path of electrical current. 2 electrical circuits are used in the production of X-rays, a low voltage and high voltage. The low voltage is also called the filament circuit, and it uses 3 to 5 volts. It regulates the flow of electrons to the filament in the cathode of the X-ray tube and is controlled by milliamperage. The high voltage circuit uses 65,000 to 100,000 volts and provides the high voltage needed to turn the electrons into X-rays. It's controlled by kV. Earlier I mentioned the step-up and step-down transformers. The step-down transformer is used to decrease the incoming voltage to the 3 to 5 volts needed by the filament circuit. The step-up transformer is used by the high voltage circuit to increase the voltage to the 65,000 to 100,000 volts it needs to accelerate the electrons over to become X-rays. An auto transformer is used to compensate and correct minor fluctuations in the current. Are you bearing with me right now? I know it's getting long, but we're almost finished. So now that we have all the details of the tube head and the components of the X-ray production, let's go over a step-by-step explanation of how X-rays are produced. First, when the machine is turned on, the electrical current enters the control panel through the wall power source. The current travels from the wall to the control panel to the tube head through the extension arm. The current is directed to the filament circuit and step-down transformer in the tube head. The transformer does its job by reducing the incoming voltage to 3 to 5 volts. The filament circuit uses 3 to 5 volts to heat the tungsten filament on the cathode of the X-ray tube. Thermiotic emission occurs, which is the release of electrons from the tungsten filament when the electrical current passes through it and heats up the filament. The outer shell electrons of the tungsten atom gain enough energy to move away from the filament surface, and a cloud forms around the filament. The electrons stay in that cloud until the high voltage circuit is activated. When the exposure button on the control panel is activated, the high voltage circuit is also activated. The electrons are pushed from the cathode to the anode. When the electrons hit the tungsten target of the anode, the kinetic energy is converted to X-rays and heat. Less than 1% of the energy is converted to X-rays. The rest is converted to heat, which shows the need for the insulating oil to absorb the heat. The X-rays produced go in all different directions, but the glass envelope keeps them inside the tube. A small number of electrons escape through the unleaded glass window. The X-rays travel through the unleaded glass window, the tube head seal, and the aluminum discs, and the aluminum discs help filter out the longer low-energy waves, X-rays. Finally, the lead collimator restricts the size and shape of the X-ray beam, and the X-rays travel down the PID and exits the tube head through the opening. And there you have it. That was a comprehensive explanation of an X-ray tube head, an X-ray tube, and how X-rays are produced to take radiographs. Hope you enjoyed.